Hi, everyone. This lecture is going to cover stoichiometry with gases. So it's a review of stoichiometry we covered last semester, but now as it applies to our gas laws. And so we're going to start off with our problem that's shown here. We're going to go through how to solve it. And so the problem says, if a car airbag contains 100 grams of this sodium azide, NaN3, so that's shown here in our equation, we want to know how many liters of gas will be produced at these conditions, 298 Kelvin at 1 atmosphere pressure. And so when we look at this, the first thing we should note is that we have our chemical equation shown here. All right, so we have to kind of walk through our steps that we need to solve this problem. So if it's helpful, we can kind of build ourselves a roadmap of the steps needed. And so first thing we should always do is check to make sure our reaction is balanced. So we have to balance our chemical reaction. All right. The next thing we're going to have to do is say, well, we want to find out the, when we look at what it's asking for, how many liters of gas. So what is our gas? What we're looking for is how many, oops, wrong one, how many liters of our N2 gas will be produced from the reaction. But we're starting with, when you look at the information that we're given to start, we're given 100 grams of this sodium azide. All right, so we're starting with 100 grams. And so when we think about how we're going to have to do this, we're going to have to first start with 100 grams of sodium azide. We're going to have to convert that into moles of NaN3. Once we have our moles of NaN3, now we're going to have to convert that to moles of N2, right? And we're going to use this a mole ratio, right? And then once we have moles of N2, now we can come up and we can go to liters of N2. And in this step, to do it, we're going to use our ideal gas law, PV equals nRT. All right, so our steps are balance the reaction. And then we have to calculate moles of NaN3 to find moles of our N2 to find volume of N2. So that's kind of our roadmap for how to go about this. All right, so again, first step is to balance. So let's go ahead and do that. We have our chemical equation. We can look at this and say it is currently not balanced. We can see there are 3 nitrogens on this side and 2 nitrogens on this side. And so we know we're going to have to balance these. So we can start off by putting a 2 in front of the sodium azide and NaN3. I'll put a 2 there. That gives us 6 nitrogens. So I'm going to have to put a 3 in front of the N2 to give us 6 nitrogens. And now we have 2 sodiums on the left, 1 sodium on the right. So I'll go ahead and put a 2 in front of our sodium. And now our reaction is balanced. Okay. So now we can start off with our calculation and say, okay, what we need to do is find the moles of NaN3. So I'm going to start off with our 100 decimal point grams of NaN3. All right, and we're going to convert that into our moles. All right, so we want grams to go away. We're going to have moles up top. So this is our grams to moles. All right, so we have grams go away. So those will go away. We'll be left with moles. And to find this value, this is our molar mass, we would go to the periodic table. All right, and then from the periodic table, we would need the mass of sodium, right, and nitrogen. And we have 3 nitrogens and 1 sodium. So we can add that together. And we're going to be left with our, in this case, I got 65.02. grams per mole of NaN3. Okay. If we stopped here, right? If we stopped here, our answer would be in moles of NaN3. We could keep going though, right? At this point, we have our moles of NaN3, but we can keep going to find moles of N2 using our mole to mole ratio. And so I'm going to add another dimensional analysis here. And we want to moles of NaN3 go away, moles NaN3. And we want to end up with moles of N2. And then here, for our values, this is going to come from our balanced chemical equation, our stoichiometric coefficients. So we're going to say there's going to be 3 moles of N2 every 2 moles of NaN3. And now we can go ahead and we can calculate that out. So if we do that on the calculator, it's helpful. We can show that sort of step. I'll bring my calculator into play. Oops, make it a little smaller. Okay, we'll just do it this way. All right, so we have clear that. 100 grams divided by 65.02 times 3 divided by 2. And that's going to give us the 2.31 to the correct number of sig figs. So now we can come back and say that's going to be 2.31 moles of N2. All right, so we're not done yet, but what we did was we found the moles of N2. Now what we have to do is do our final step. The question asked for liters. So now we have to use the ideal gas law, P equals nRT, to solve for our volume. So we can go ahead and do that. We know our moles, so we have our PV equals nRT. We're solving for volume. So volume is equal to nRT over P. And we can remind ourselves, what do we know? We know N is the 2.31 moles. We know R, that's our constant, 0.08206, right? And that's liters, atmospheres, mole, Kelvin. And in this case, we're told our temperature is 298 Kelvin. Right? And our pressure is 1.0 atmosphere. So now we can plug in. And so we have our 2.31 moles. And then times R, 0.08206 liters times atmospheres per mole times Kelvin times 298 Kelvin, and that's all over 1.0 ATM. There's 1.00 sig figs, and now we can sort of calculate that out. And so we can go back to our calculator, bring that up, bring that over. And so now we have in our calculator, we're going to have our 2.31 times 0.08206 times 298 divided by 1. And so we get 56 to sig figs, 56.5 liters. So now we can come back and say our volume V is 56.5 liters. And here is the answer to the question. So when we look at this, go back to that question, it says, in our car airbag, if we start with 100 grams of NaN3, how big does our airbag inflate? And we're going to produce 56.5 liters. So we go from 100 grams, which is pretty small solid material, to a huge volume of gas, which inflates your airbag and keeps you safe in case of an accident. All right, so that's how we would solve that problem.